Hello students, today we are going to discuss the important topic, that is reaction mechanism, organic reaction mechanism. You know, the nature of product of organic reaction depends upon the mechanism, and it also depends upon the nature of reactant and the nature of reagent used. Today we are going to discuss some important reactions and its mechanism. That all mainly organic reactions, if you see, either it is substitution, either electrophilic, nucleophilic, if addition, electrophilic addition or nucleophilic addition, if it is or your free radical substitution, free radical addition, like this. But some important mechanism highly essential to know the to apply this mechanism in different reactions. Now let us discuss some important mechanism, substitution and addition mechanism. Let us start from that SN1 mechanism. SN1 mechanism already we have discussed. We will discuss only direct examples. I can give the mechanism of particular reaction. In SN1 mechanism, already know it is that two-step process. The two-step process. Two-step process, and here first step is formation of carbocation, and second step is the attacking of nucleophile. For example, you take this CH3 whole 3 CCl with aqueous KOH, produce CH3 whole 3 COH plus KCl. Here haloalkane nature is tertiary. Here why tertiary haloalkane gives SN1 mechanism? Because the first step is the formation of a carbocation which is stable. That's why all tertiary haloalkane involves SN1 mechanism. Because the first step is the formation of carbocation which is more stable if you take tertiary haloalkane. This is the example. How can we explain the mechanism of this SN1 mechanism of this reaction? Particular examples. Here, step 1. Step 1 is the formation of carbocation. First step is the formation of carbocation. CH3 whole 3 C whole plus and Cl minus. So this step is the formation of carbocation. This step is a slow step. So slow step means rate determining step. So formation of carbocation because stable. It is stable carbocation. That's why first step is the formation of carbocation. Then step 2. In step 2 what happens? This carbocation which is produced in the first step, it reacts with nucleophile. Reacts with here nucleophile is OH minus. And this step is first step, not slow step, it is a first step, and forming as the carbocation is planar, it is planar shape, and it is planar, OH minus can attack left back side or front side. So produce a mixture of plus and minus, a racemic mixture of CH3 whole 3 COH. Always the product is racemic mixture. A racemic mixture of product will be formed. So this is the nature of reaction of SN1 mechanism. First step is formation of carbocation. Second step is the very first step. And if you see the right, the rate determining step, dx by dt is equal to k, r is slow step. It depends upon only concentration of reactants. Only concentration of reactant depends. It does not depend upon the concentration amount of that nucleophile used. Only depends upon how much of reactant or substrate you have taken, because it is the slow step. So this is the SN1 mechanism. Which type of reactant generally produce? All tertiary haloalkane and also benzyl group PHCH2Cl. It also produce stable carbocation. Allyl CH2 double bond CH2Cl. It is also, this is allyl. You remember which is mainly produce SN1 mechanism? Benzyl, and this is tertiary. Mainly this type of compounds always shows SN1 mechanism. Two step. First step is the slow step, formation of carbocation, and second step the attacking of nucleophile to the carbocation. As carbocation is planar, it has free end. Both sides are free, so produce plus and minus product of that product, which is resin mixture, because both plus and minus are produced. So this is the mechanism of SN1 mechanism. Let us discuss another example. We are discussing mainly examples. Already theory already we have discussed in the previous lessons. So SN2 mechanism. The SN2 mechanism mainly it is a one step, both attacking of nucleophile and releasing of leaving group in one step. Okay. So here take one examples, that is methyl fluoride with aqueous KOH forming methyl alcohol and KCl. Here it is when the nature is primary, the haloalkane should be primary, where as it is attacking primary because the carbon atom is free, so that nucleophile can attack freely to the carbon atom in which the leaving group is attached. The carbon should be free. That's why primary haloalkane is the best reactant for the formation of product by SN2 mechanism. Here it is a one-step mechanism. Here you can write the mechanism like this. Here OH minus, that is your nucleophile, when you are that this is your substrate, I have written like this. Here what happens, this carbon is free. Primary means the carbon atom is free. No bulky group attached to the carbon. That's why as it is free, so OH minus attached to back side of the leaving group. This then same time leaving group is released. So attacking and releasing occurs at the same time. That's why it is proceed in transition state. Height of right transition state. OH minus dot dot dot. Here what happens? And this is your leaving group. Both that attacking and releasing occurs at the same time. OH minus moving towards carbon, at the same time leaving group is releasing from the carbon. So it is called transition state. It is a one-step process. Both attacking and releasing, one-step process. No intermediate is produced. Only proceed through transition state, attacking and releasing, and the result is lastly. The result is your CH3OH as is attacking from backside. If it is plus isomer, the result will be minus isomer. Inverted product will form and your Cl minus will be released. So it is inverted product. Just if you see optical activity, just opposite. If you have taken plus, result minus, because attacking from backside. It is one step process. SN2 is one step. And it is What are the examples? Mainly primary haloalkane, methyl chloride, generally ethyl chloride, ethyl chloride, you can take this. Okay, so this mainly produce SN2 mechanism, because the here the both in case this if you see the carbon atom is free. If you see the reactivity, methyl chloride is more reactive than ethyl chloride towards SN2 mechanism. If you see SN2 mechanism, which is faster, methyl, because methyl is totally free. That's why free carbon will show SN2 mechanism, and bulky carbon only shows SN1 mechanism because due to formation of carbocation. So this is the important mechanism of SN1 and SN2 mechanism with examples. Any example will given, you will do in this way. You have to see the nature of reactant. What type of reactant is used? If it is primary nature, SN2 mechanism. If it is tertiary nature, then it use SN1 mechanism. So this is the two examples of SN1 and SN2 mechanisms. Now we will discuss some other, that using some application of this nucleophilic reaction, and some other addition reaction we will also discuss. Okay. You complete this one, then I will erase this. Now I will discuss another examples, another mechanism, that is hydration of alkene and dehydration of alcohol. Both reactions related to your addition and substitution mechanism in both cases. Let us discuss this one. If you take any alkene, hydration of alkene in presence of H plus ion, that is sulfuric acid, produce CH4 CH3 alcohol. How can you discuss the mechanism? Here mechanism is like this. First step, that is, we will take alkene, addition of H plus ion. As it has pi bond, source of electron, so it will attack the electrophile. First it will attack the electrophile. When it will attack the electrophile, which is electron deficient, it will donate electrons. So out of two carbon, one carbon will be electropositive charge, becomes carbocation form, because after losing electron. So we have to see which carbocation will be better. We know the stability of carbocation, tertiary is greater than secondary, greater than primary. Here only secondary is possible. So if you write this, the product will be RCH plus and CH3. When H plus is added to pi bond, the pi bond breaks and adjacent carbon become carbocation form after displacing the electrons. And the secondary, here the secondary carbocation is produced. As a secondary carbocation is produced, which is stable, this is the formation, first step, formation of carbocations. This is a slow step you can take. Then second step, what happens? This carbocation, as it carry positive charge, so it is attacked by nucleophile. Here nucleophile is water, having source of electron, that is lone pair. So this process is a fast process, attacking of nucleophile to the carbocation, because positive charge and lone pair attraction is very fast. So it is a very fast, that is a fast reaction, formation of this CH then OH. After donating electron, what the carbocation? You have to show like this. Then formation of this, and here oxygen will be plus charge. Then when oxygen will, this first step is called protonation. This step is called protonation. You can write also. And second step is addition, attacking of nucleophile. Then third step is what happens? This CHOOH is losing H plus ion. It losing H plus ion. It loses H plus ion. The product is RCHOH and CH2. This is the product. And this step is also that loss of H plus. This is your first step also. And the formation of alcohol. So in three steps, first step is called protonation. This is called protonation reaction. Protonation, and that is attacking the nucleophile to the carbocation. Then this is called deprotonation. Deprotonation, loss of H plus from the product. That product is produced by the attacking of nucleophile. Then it uses H plus ion. So if your H plus ion acts as a catalyst, it is just used in the first step, then reappear in the last step. That's why it acts as a catalyst. So this is hydration of alkene in three steps. Any alkene, that hydration product, you will be write this thing, or you can use also hydroboration. Other examples, hydroboration technique can be used. That preparation of alcohol. Then come to this second examples, that dehydration of alcohol. Dehydration of alcohol means alcohol when undergo dehydration, loss of water, it will produce alkene. For example, you can write this. You take one alcohol, CH3, CH2, OH. Dehydration alcohol in presence of generally sulfuric acid, concentrated sulfuric acid produce alkene and plus water. Here the product alkene depends upon, it always follow the Sedgwick rule. The product always follows Sedgwick rule. Here the product follow that Markovnikov's rule. The hydration of alkene follow Markovnikov's rule. It will follow Markovnikov's rule, and this follow that Sedgwick rule. Because elimination always follow Sedgwick rule, and addition always follow Markovnikov's rules. Here, what is the mechanism? Mechanism like first step. The mechanism is like this. The first step is protonation, CH3, CH2, OH. Then protonation is the reversible nature, that is called protonation. The reaction is protonation, formation of protonated alcohol. First step, formation of protonated alcohol. Then second step, what happens? This CH3, CH2, OH2 plus, then what happens? And this is your that first reaction. It is a first reaction. Then what happens? This reaction, that CH3, CH2, OH minus, then undergo loss of water, that is dehydration. That is called dehydration. So dehydration occurs. Already I am doing dehydration alcohol. So when dehydration occurs, forming carbocation, and this is your slow step. This is your slow step. After that dehydration of alcohol, that is a slow step because formation of carbocation. Then third step, what happens? This carbocation loses here. This carbocation loses one H plus ion and forming alkene. This step also, that is first step, formation of alkene. So just you see, first step is the protonation, formation of that protonated alcohol. Then in the second step, protonated alcohol loses water molecule forming carbocation. This carbocation then loses H plus ion forming alkene. So the formation of alkene depends upon the nature of alcohol taken, and it follows the Setzer rule. Already we have written the Setzer rule states that what the product of alkene produced should be highly substituted. Alkyl substituted alkene is the major product. This depends upon your product. If more substituted alkene is alcohol is taken, then product of alkene should be more substituted. That is your Setzer product. But we have to remember the steps. Here first protonation, then dehydration, then deprotonation. It is called deprotonation. That is deprotonation. For example, if you take this alcohol, CH3, then CHOH, then CH2, CH3. So the major product will be concentrated sulfuric acid. The major product will be more substituted. So this is the more substituted product. CH3, CH, double bond CH, CH3. So this is the product. Plus minor product is CH2, double bond CH, then single bond CH2, CH2. So this is the major, this is your major product, this is your minor product. Okay. So this elimination reaction, this is called elimination reaction, this is called addition reaction. Addition reaction follow Markovitch's rule and elimination reaction follow Setzer rule. So if the product, nature of product depends upon the reactant used, but it follow this mechanism, three-step mechanism. Here also three-step mechanism. Which step is slow, which step is fast, you have to remember. So this is the mechanism of dehydration alcohol and hydration alkene. Alkene from alcohol, this is the what? This is the alcohol from alkene, this is the alkene from alcohol, just opposite. And mechanism also, one is your addition mechanism, here also elimination, mainly elimination mechanism, this is your addition mechanism. Okay, thank you all.